Good evening. In this video, we are going to discuss proposition 1 from book 3. So this proposition states that if we are given a circle, then we are able to construct, or let's say we are able to find the center of this circle. Okay, so let's try to construct that center and give it a proof. So first of all, let us randomly pick up 2 points on the circumference, for example, A and B, and let us join AB together and bisect AB as a point of C. Apply proposition 10 from book 1. Okay, so we can bisect it. So let's assume this is point C, bisect it AB. Okay, and then let's apply proposition 11 from book 1 to construct a straight line at point C that is perpendicular to AB and assume it meets the circle at point of D and E. Okay, then let us apply proposition 10 from book 1 again to bisect DE as a point of, for example, O, and the point O is the center of this circle. Okay, so let's give it a proof. So in order to prove it, let's use the method of contradiction again. So the first step of a contradiction is that making a hypothesis that is against our proposition. So let's assume O, the point O is not the center of the circle. Okay, so it's not. And based on this, we can randomly pick up a point in this circle, for example, P here as the center of this circle. So let's assume P is the center. Okay, then let us join PA and PB respectively. PA, PB, also join PC. Great, and let's see what we can derive from this hypothesis. So please recall definition 15. In the circle, all radius are equal. So let's say P is the center of the circle. So PA must be equal to PB, right? Because they are radii of this circle, of the same circle. And we know PC is equal to PC. Besides, we know AC is equal to BC, correct? Because C bisects AB. And if we combine them together and apply proposition 8, side, we know triangle PAC is equal to triangle PBC, correct? So we can derive that angle PCA is equal to angle PCB, correct? These two angles are equal. And please recall definition 10 from book 1. If two straight lines are meeting with each other and the two adjacent angles are equal, so for example alpha is equal to beta, then these two straight lines are perpendicular to each other and these two angles are right angle. This is the definition of right angle. So we know that PC and PAB are meeting at the point of C, and we know that these two angles are equal. So we know that angle, for example, let's mark it as angle 1. So angle 1 is equal to a right angle, correct? Okay, and we know that DE is perpendicular to AB, correct? So we also know that angle DCB is a right angle, correct? So combine them, we can conclude that angle 1 is equal to angle DCB, correct? But have a look at this figure, we can conclude that DCB is a whole, meanwhile 1 is part. So which means we conclude that the whole is equal to the part which breaks combination 5. Whole is always greater than the part. So this means our hypothesis is false. So our proposition is true, correct? Which means point O is the center of this circle. So we have finished our proof and construction. And I would like to say, based on this proposition, we can obviously conclude a corollary that if two straight lines meeting with each other, for example in the circle, and one straight line is bisecting another straight line at right angles. So here, for example, we have DE is bisecting AB at right angles. With this condition, then with this corollary, we know that the center of the circle must be lying on the cutting straight line. So which means the center of the circle, for example O, it must be in or must be on the cutting straight line. Cutting straight line is DE. It bisecting another straight line at right angles. Okay, so this is corollary. Okay, and that is the end of the video. And in the next video, we are going to discuss proposition 2 from book 3. Thanks for watching. Have a good day.